Yo, what's up, hobbies? Welcome back to a new video. Today we're gonna be talking about the full bridge rectifiers. Yeah, the full bridge rectifiers. Yeah, I normally get amazed when Electro Boom actually uses like
full bridge rectifier.
I get it. Now the full bridge rectifiers actually consist of 4 diodes. Yeah, 4 diodes. Actually, the 1N4007 type of diode which are connected together to create the full bridge rectifier. So you can find a lot of full bridge rectifier circuits such as inverters, chargers, and other electronic stuff. But yeah, this is where they're found, and yeah. With the labeling on the white side actually called the anode and the black side actually called the cathode. Also be aware that there is a breakdown voltage for these diodes, and once you exceed the breakdown voltage, the diode will go boom. So depending on your type of project, current draw, depending on the type of diode which you will use, you can find a lot of diode in different shapes and different sizes according to the current which you are dealing with. And also the full bridge rectifier is made in one IC chip. Yeah, not actually one IC chip, it's packed in one chip. Check it out. This is the full bridge rectifier with all 4 diodes inside, and as you can see the polarity, you can just connect these to your project and convert AC to DC. Very simple. But in this video we're going to be using the real 4 diodes for more explanations and more understanding of the knowledge. And if you haven't subscribed, hit the subscribe button. You're going to learn a lot. Also, I don't know if I already mentioned it, but the diode also have a peak inverse voltage like when it's exceeded, it go boom. Yeah, I already said it, so yeah. Okay, now talking about how diode works, actually I just get some ideas from ChatGPT. I'm gonna be summarizing it at the end, but let's just get a simple tip from ChatGPT, and if you have any doubt, let me know in the comment section below and I'll answer you perfectly. Now, first off, positive half cycle. Yeah, during the positive half cycle AC, the positive half AC cycle, 2 diodes, let's say D1 and D2, conduct, allowing current to flow through the load in one direction. This makes the output voltage positive. Second, the negative half cycle. During the negative half cycle of the AC power line, the 2 other diodes, let's say the D3 and the D4, conduct. Even though the AC input is negative, the diode arranges the current flow so that the output remains positive. Yeah, even though it's negative is dealing with, the diode arranges to the current flow to positive, so you get a full straight line positive. And then the result, the output waveform is a series of positive poles effectively smooth out AC input into DC. Yeah, now this is very simple. Now let me summarize it for you. Now picture this is a square wave. Now imagine we want to convert this square wave into a straight line. Yeah, we want to convert this square wave AC into DC. Now let's say the D1 and D2 diode passes this on side. Yeah, this on section, it passes this on section, but it blocks the off section right here. Yeah, this allows only the on section to pass, and when the other 2 pair of diodes, which are the D3 and the D4, passes this off section, it blocks the on section, creating a straight line. Now picture this: if you join all the section which is actually only turning on, it will form a straight line. Now you can see the straight line, which it's actually the DC. You can see the trick, you can see the magic. It's not actually magic, it's just like when the 2 segments of the diode passes, it does not allow the other one to pass, and when this one passes, it does not allow the other one to pass, creating a straight line. I don't know if you understand it. Just let me know in the comment section. I'll make more explanations, but if you don't understand, repeat my explanation. Just go back and recap it again and you will understand it very well. As I said earlier, the on side passes, it blocks the off side, and when the off side passes, it blocks the on side, thereby creating a straight line. This repeats rapidly, and thereby creating a straight line, which is actually the DC. This is how it works, and if I'm kind of too fast, you can reduce the speed on the YouTube setting. It's simple to do. Let's just quickly go to the building of the project.
Now just wait a second, I almost forgot. Normally the current waveform which is going to be coming out from the full bridge rectifier is actually positive. As I said earlier, the diode actually only passes positive. Yeah, even though it's negative that it's passing, the diode somehow converted to positive, so there is only positive waveform. With the help of the capacitor, it's smoothing all those waveforms to make it somehow straight like a DC line. So you're not going to get the full straight DC output from the full bridge rectifier without the capacitor. So it's efficient and it's definitely good to add the electrolyte capacitor. I'm using 4700 U. If you can use any other type more than that to make your circuit more perfect. And yeah, so just get the tip. Let's go to the next one.
Now here is how I'm gonna build it. Listen attentively. I'm not gonna be connecting a direct 220-volt AC power line to the bridge rectifier, then measure the output of the bridge rectifier, and to kind of tell you that it actually come back. That is definitely dangerous. I know I can do it, but just on the safer side for you also to experiment at home as a hobbyist, I am going to be creating a frequency generator using the 555 timer IC chip. Yeah, I'm going to be creating a frequency using the 555 timer, about 10 haze that will blink if I connect a bulb. Yeah, I'm going to be generating 10 haze from the 555 timer so that when I connect a LED to the output of the 555 timer, it will blink out. And I'm going to be connecting that output of the 555 timer, which is actually pin 3, to the input side of the full bridge rectifier. Then we're going to be seeing the output of the full bridge rectifier to actually see if it actually regulates the voltage, if it actually converts the voltage. You're gonna love this idea. Do well to subscribe and let's dive in. Now I'm not going to be starting afresh on how to build a 555 timer frequency generator. I made tons of video for that. You can go check it out, link in the description, or check the link above. Check the tag above to get to a video where I build this project. But this is it. I created a 555 timer frequency generator square wave to produce 10 haze using a 10 kilo ohms resistor on R1 and also a 10 kilo ohms resistor on R2, actually a potentiometer in R2, and one UF capacitor for the charge and discharge process, and 102 PF capacitor to 5 actually to pin 5 of the 555 timer, then to ground to create a good filter for the circuit. And let's test it out. Okay, everything is connected successfully. Testing it out for the first time. Boom. Oh my god, I know you will see the ripples on the oscilloscope. I know. I didn't mention this. A full bridge rectifier also need a capacitor. Yeah, you can use an electrolyte capacitor for smoothing. Yeah, it's definitely really important. So you should put it at the output of your full bridge rectifier to filter out noises and make your line straight. And check it out when we added the capacitor. Boom, you can see the trick and the magic. So don't ever forget to put the electrolyte capacitor. It helps a lot to clear noise and filter everything out. Just want to say thank you very much for watching this video to the ending. I hope you really enjoyed this video. If so, don't forget to hit the like button, subscribe to my channel, and also support me on Patreon. Do also well to share the video with your friends that want to also get the knowledge. Thank you very much, and I'll catch you guys in the next one. Peace.